Voltage dividing is the breaking up of supply voltage into various parts. Let's always remember that in a series circuit, voltage measured at one point may not be the same thing as when measured in another point. This is because of the different electric potentials that you have at different points in a circuit. In a parallel circuit also, voltage is always the same. This is because the two ends of the parallel path have the same potential each. Let me explain better. If you have a circuit diagram like this, supply comes from here and goes through to this part. The electric potential at this point is going to be different from the electric potential at this point, and it's going to be different from the electric potential at this point. So if you measure out the voltage here, it might actually be different from the voltage here. That's because of their different electric potentials. So you see, voltage in a series circuit is unequal. But in a parallel circuit like this, you can see that the potential here is the same thing as the potential here. Potential here is the same as the potential here. So the voltage here is equal. The voltage here is equal to the voltage here. Same goes with current. In a series circuit, in a straight path, current is always, in a straight path like this, current is always equal because it's the same throughout. But in a parallel path, current divides, and this is a fundamental law that we understand in electronics, that once you come to a junction like this, current divides according to resistance. So now let's look at voltage division. If, for instance, in a circuit like this, we expect a total of, in this whole circuit, 10 ohms, and we are expecting a current of 1 amp through it. If, for instance, the resistance here is 5 and the resistance here is 5, let's calculate the voltage across this resistor. Don't forget, V is equal to IR. So the voltage across this resistor is going to be 1 times 5, which is equal to 5 volts. And voltage across this resistor is going to be 1 times 5, which is equal to 5 volts. Now what if this was 8 and this is 2? So the voltage across here, if this was 8 ohms, is going to be 1 times 8, which is equal to 8 ohms. And voltage here would be 1 times 2, which is equal to 2 ohms, which is equal to 2 volts. I'm very sorry about that. 2 volts, 2 volts. Yes. So you can see 5 volts plus 5 volts equals 10 volts. 8 volts plus 2 volts equals 10 volts. The voltage is being divided due to the resistance, and you can see the greater the resistance, the greater the voltage. The smaller the resistance, the smaller the voltage. And if you wanted to calculate the total voltage from here, V is equal to 1 times 10 volts. You can see it's the same with this. So this has brought us to the conclusion of, to calculate the total resistance in a voltage divider, which is this is what you call a voltage divider. When you put resistors in series and you tap out from a particular resistor the amount, based on its ratio, the amount of voltage you want. We've come to a final conclusion that you pick the resistor you want, resistor X, all over the total resistance in that series circuit times your total voltage in the series circuit, and this will give you the voltage across resistor X. Now let's apply this formula to this. If this was 8 volts as we expected, as we wanted, if this was 8 ohms as we calculated here, we would have 8 over the total resistance 10 times the total voltage 10 volts, which is equal to 8 volts. Same thing for this. Let's calculate this. If it was 2 ohms, we have 2 over 10 times 10, which is equal to 10, which is equal to 2 volts. This is the basic idea of a voltage divider, and it is very important in electronic circuits. I hope you enjoyed this video. Don't forget to like and subscribe. This is Ellison. Bye for now.